Yes, Vinny, please go ahead. You raised your hand.
Yeah, Smith, over to you. You'll start with the introduction and with the day one for DevOps Master Program.
Sure, sure, sure. Thank you so much. So, first of all, I welcome you all in DevOps Master Program, which is organized by Network Kings, one of the renowned organization which works on multiple courses which are spread across networking, DevOps, all the cutting edge technologies which is there in market as of now. And this with this course, you'll be gaining all sort of knowledge which you need to work efficiently on enterprise level industries in DevOps and pipelines and automation and a couple of other things which we are going to talk about in our session. So with this, let me quickly share my screen. I'll start with my introduction first, and I'll give set some backgrounds, all the timelines which I'm going to discuss, what timelines will be there for this course, and what timeline is for the ongoing module. And post that, we'll discuss about all the break timings which you're going to get in case if you need for sure, and a couple of other things. So let's begin. I'll begin with sorry. I'll begin with the day one course curriculum, day one agenda, which we will have. So, friends, in day one, we are going to talk about our first module, which is Linux. While we are talking about Linux, we certainly will do certain hands-on because this course will be about Linux, Linux basics, and shell scripting. So eventually you will have to create or you have to write shell script on your own. While you are doing that, you have to set up your own lab. I'll be guiding you how to set up your lab, how to have a Linux configuration done. Let it be your Windows or let it be on any other cloud platform which you're using to have Linux terminal open with you. That is what we're going to talk about in our session. When I'm delivering this training, because it's going to be pretty much long, 80 hours, and every day we are going to have 90 minutes session. So almost it's going to run for nearly 2 months. And whenever you'll have doubt, whenever you'll have concerns about any of the topic which I'm talking on, feel free to post your queries. There are three different means by means of which you can post your query. Either you can unmute yourself, talk on it, talk about your questions, queries. You can post your queries there in our meeting chat, or you can just raise your hand. I'm regularly monitoring chat as well as your hand raise so that in case if you do have any queries, that will be addressed as soon as possible. When I provide trainings, when I cover up any topic, I go in certain flow. I will give regular pauses at certain after completion of each of my flow. But in between, if you do have any questions, feel free to post your questions there in your meeting chat. Hello, Bunny. Like the way, Bunny. And I believe the chat option is visible to everyone, all the participants. So in case if someone is posting any question query, then that question will be visible to everyone. So I believe questions are pretty much important because your question can benefit others. Perhaps others do have certain doubts, and those doubts may not trigger at right intervals, but your questions can help others understand about others clarify their doubts, right? So yeah, feel free to ask your questions. Feel free to ask your queries. Raise your hand. Just unmute yourself and talk. But as I said, I'll give a pause with certain regular intervals. Other than that, hopefully it's since it's a 90-minute session, not that long. So I'm not expecting any breaks as such. But in case if you need any break, if you because you are going to have certain heavy topics as well, in case if you need break, please let me know. We'll certainly manage that part as well. So I welcome you all again in this DevOps Master Program session offered by Network Kings. And we'll start with our first module, which is in our day one, which will be Linux and Linux scripting. This module will be of 5 hours. In this module, we are going to talk about what Linux is, basics of Linux, and then we'll switch into Linux scripting, Linux shell scripting, wherein I'll give you ample amount of idea on how to write any automation script, any shell script as such. So it seems first question by Bunny, can you take doubt questions at the end of the session as it will not alter the flow of the session? Just a request. Fair enough, Bunny. I don't have any issues. Though, in case if you feel as if your next set of understanding depends on ongoing topic, ongoing doubt clarification, feel free to ask it. So do not wait for your questions to be answered or addressed by end of session, though that's a good idea, Bunny, because that won't disturb my flow. It's great for me in case if I get an opportunity to clarify all the doubts, all the questions by end of session. But many times your next set of understanding will depend on your ongoing topic, right? So clarifying interim doubts are also equally important, but I'm equally good with anything. Okay, so let's first start with our Linux session. So let's understand what Linux is. We will go pretty much slow, wherein because I don't know what all backgrounds you all belong to. You do have any coding knowledge, scripting knowledge as such, or you are pro in Windows but never saw those black screens of Linux or never saw black screen which is present in Windows even. So I'll go pretty much slow, and gradually as class proceeds, you'll be able to understand what Linux says, what black terminal of Linux does mean, and how to work on black terminal of Linux. And gradually from there, we'll just catch up certain pace. Uh, this class is mostly in English, so let me know your preference, Soumya. But let's begin, friends. So, what Linux is and who developed Linux? What does actually mean when you say Linux? Okay, Hindi. Let's continue in English because I believe we do have majority of candidates, and this video is streaming live as well. So I believe it will be more good in case if we can continue in English because majority of the participants will understand because we do have wide variety of participants and they are from different regions in a country, and majority of us do understand English rather than Hindi, right? So let's continue in English. In case if you do have any doubt, Soumya, Dheeraj, maybe we can just get along with that and I'll help you to understand those doubts in pretty much granular way so that more or less you'll be able to catch up the context. Fair enough. So let's begin. So let's start with history of Linux. So what Linux is, when Linux is developed, who developed Linux in the first place. We'll start from that place. So friends, Linux is an operating system which is developed nearly 3 decades back. Can you imagine? 3 decades back, more than 3 decades back, it's been developed. It was developed by one of the Finland software engineer. His name is Linus Torvalds. He developed Linux in the first place, along with a company whose name is Free Software Foundation, FSF. So it was developed nearly 3 decades back, and gradually from that point of time, we have seen lots of improvement, lots of modifications in Linux because from that point of time every community member, developers or DevOps engineers like you, me, and others, started contributing into Linux. And they kept on developing Linux and made it so robust that now, friends, 90% of enterprise level organizations are using Linux. I'm not saying that Windows is not in use in enterprise level organization, but Linux got its own place. And 90%, more than 90% of enterprise level organization do have 70-30% ratio. 70% of their servers operating systems are running on Linux and 30% are on other operating system, right? And that is where the popularity of Linux can come in. Now you can imagine how popular Linux is and from where it was developed and from where it was originated. Somewhere in 90s it was originated. Okay, so the first thing which we are going to talk about is we will talk about what Linux architecture is. I'll be sharing certain images as well, with which we'll go over Linux architecture. I'll be sharing you certain references as well. And to just understand, to just make you understand your level of understanding, what we'll have is we'll have certain quizzes also by end of each module so that you can judge yourself on the understanding which you're getting in your class, right? So let's start with Linux architecture, friends. But even before we get into Linux architecture, even before we understand what Linux architecture is, I will start with a basic question of what an operating system is. So can anyone help me understand what an operating system is? What is your understanding on operating system? What do you understand when I say operating system? Anyone do have any idea on that? A brief answer will help. Okay, no problem. I'll gradually begin. So, what an operating system is? An operating system, friends, can be described as an interface because we see operating system. Windows is an operating system. It can act as a medium between hardware and software, right, Soumya? That's great. Any other? Anyone else? Please keep posting your answers in case if you do have. Okay, so what an operating system is? Operating system, like the way Soumya said, it acts as a medium. It's a medium between hardware and software. Basically, it's an interface, friends. Interface among the computer hardware and the user of any computer. I, being a user, will be able to interact with any of the computer application. I'll be able to interact with computer hardware by using something called operating system. It is a group of software that handles the resources of the computer hardware and facilitates basic services for computer programs, right? It facilitates different programs which runs on our computer. Now, friends, quite similar to any operating system. And when I say any operating system, since I know that you all will be pro in Windows or maybe pro in Mac or other platforms, similar to that, Linux operating system is also one of the operating system. Vineet, that's fine if you can turn on your video, that's okay. But yeah, even though if you turn it off, that's not a problem. So Linux operating system is one of the famous versions of Unix operating system. So we do have Unix operating system. And Linux operating system is one of the operating system which we normally use, which we normally set up in Unix. So Vineet, you raised your hand. Do you have any question? Okay, no problem, Vineet. In case if you don't have, please drop it down. Now, Linux is one of the, as I said, one of the famous version of Unix operating system. Linux is an open source Unix based operating system. And the main component of Linux operating system is its kernel, right? Its kernel. Bunny says system software that manages computer hardware and software resources. Absolutely right, Bunny. It is the operating system. And that's what an operating system does. The main component of Linux operating system is something to which we call as kernel, right? It's not kernel kernel, it's kernel kernel, right? So what this kernel does? This kernel is something by means of which we'll be able to we'll be able to make shell interact with hardware. What a shell is, what hardware components are, we're going to talk about in a few minutes. Now, Linux is one of the only open source operating system, friends. Hope you're aware that when we have to use any of the Windows based operating system, we have to purchase licenses. It incurs certain cost. But Linux is something which is absolutely free of cost. It is open source, wherein the kernel, as you can see in this diagram, the kernel is something which is hub of the operations, right? All the activities which we performed on Linux is via kernel. It goes through kernel. Other than that, we do have bootloader, we do have graphical server, we do have daemons, we do have desktop environments, we do have application software, all play a part in Linux operating system, friends. We are going to talk about that. We are going to get a brief idea about bootloader is. Now, friends, why we are even covering these topics, let's try to understand it. And there will be certainly a question gradually, not so soon, but gradually a question might be in your mind. Why we are covering even the basics, such basic or operating system level details of Linux. So, friends, going forward, as I said, 90% of enterprise level industries are using Linux, and gradually, when you start working in Linux, basic granular level idea, a kernel level idea, a core level idea on Linux is going to help you a lot in building your basics, in building your DevOps methodology, mindset, which we are going to learn entirely on Linux, right? So you're going to learn a lot on DevOps, but you should have some basics. You should have your foundations perfect, strong enough, so that say tomorrow you sit for interviews, or tomorrow you will be approached by an enterprise level organization, you should be good enough to answer all those queries. Perfect. So kernel does that. Kernel is the hub, as we discussed about. Kernel is the hub of an operating system. So a few minutes back, please tell us what are the similarity in Win or Linux and how it is different from Win. Dheeraj, we are going to talk about that. And I'm going to create an anomaly of what all things you get in Windows and how it matches with Linux, how it even differs with Linux. And that is where when I said, when I was talking about open source, I said that in Windows, when you purchase any licenses, for when you try to install any licenses or when you try to install any operating system, you have to purchase licenses. But Linux is an operating system which is absolutely free of cost. And now I'm going to cover a fantastic topic because many of the uh, many times I've seen having a doubt on what exactly open source is. All right. So, what exactly open source is? Do you have any idea, friends, what an open source is? When I say open source application, open source software, what does it actually mean? What is your understanding on an open source software? Any idea, friends? Anyone can use the source code. Fantastic, Soumya. Anyone else? Anyone else? Okay, so what open source is, like the name says, open source. And friends, with the advancement of technology, with the advancement of digitalization, we are at a stage now where we understand it pretty much well that any of the application runs through certain source code. At the back end of application, certain source code runs. Whenever you press power button on your Windows, a number of processes runs at the back end, right? Those are applications. Those applications consists of certain source code. So any of the application comprises of source code, friends. So when I say Linux is one open source operating system, what it basically means is its source code is free to use, absolutely free to use. And who manages it? Right? Because if it's free to use, certainly perhaps either everyone will be managing or no one will be managing. But now we are at the finest stage wherein we use best version of Linux, which we are going to use, which we use every now and then in enterprise level organizations. We use the finest version of Linux. So who manages it if it's open source? So friends, community manages it. Like developers like you and I, DevOps engineer like you and I manages Linux. We contribute to its development. We write our custom related configuration and we publicize it so that anybody can use it. So we manage it.
Hello.
Just like Windows or any other operating system, let it be Mac, let it be Windows, this operating system is the core of Linux distribution, right? So Linux is the core of any of the Linux based distributions. It links the hardware to the user and runs wide variety of programs. So Bunny says a program we can see whose source code is made available for use or modify. Absolutely, Bunny. And that is where any of the custom user can modify it, can provide their inputs, and can make configuration changes of operating system, right? Absolutely, Bunny. That's absolutely right. Great answers, friends. Great answer. Sound नहीं जा रहा आपके पास. No, Vinith, I'm unable to hear you. Perhaps check your mic.
Hello.
Yes, you're audible, Vinith.
Yes. Hello, sir.
Yeah, please go ahead, Vinith. You're audible.
सर मुझे ये लिनक्स कौन सी कंपनी में काम आता है सर, ये विंडो?
किसी भी कंपनी में आएगा दोस्त। सो विंडोज तो आप हमेशा यूज करते हो, राइट? नाउ लिनक्स इज
विंडो
समथिंग व्हिच यू आर गोइंग टू यूज व्हेन in let it be any of the company. I'm not sure आपका प्रोफाइल क्या है, what is your profile in it? Maybe we can talk about your profile and about your usage
सर,
of Linux post session as well. Please stay with me post session. But to answer your question as of now, Vinith, Linux is something, Linux वो ऐसा एक operating system है which is currently used in wide variety of enterprise level organization. किसी भी organization में आप जाओ, for sure Linux will be a topic, Linux will be an operating system, Linux will be a server, just because you will be using that, you will be executing commands or whatever you are doing as of now in Windows, आप उसमें कर रहे होगे।
मैंने देखा नहीं है ना लिनक्स कोई भी कंपनी में। मैंने 4-5 कंपनी में वर्क करा है, अभी तक लिनक्स काम नहीं करा मैंने।
अभी देखोगे दोस्त आप, मैं आपको दिखाऊंगा। हम वही सीखेंगे अपने सेशंस में, राइट?
लेकिन सर मैंने सीख रखा है लिनक्स, लेकिन काम नहीं करता।
ओके ठीक है, हम बात करते हैं इसके बारे में पोस्ट सेशन, आप रहिएगा मेरे साथ, हम बात करेंगे, फाइन? ठीक
ओके
है,
सर, ओके।
ओके। नाउ लेट्स मूव फ्रेंड्स, Linux systems architecture. So we are talking about Linux system architecture, wherein we'll discuss about what hardware is, what kernel is, what shell is, applications and utilities, and a couple of other things. So what kernel is, and that is one of the topic, one of our agenda in today's discussion, what kernel is. So now kernel is one of the core section of an operating system. Like the way whenever we boot our Windows system, your operating system boots up, it follows certain procedure, right? It follows certain procedure. Like the way whenever you go to task manager, you see a number of daemons running. Perhaps you would have never seen those tasks actually running in your task manager. For example, if you go to your task manager, you will see number of daemons, number of processes, the number of things runs, which actually utilizes your CPU, which is not there in task manager. So what they actually does, they actually create your dashboard. They actually let your keyword work. They actually let your keys in your keyword accessible. Now, question might be there in your mind. You might be asking, hey, Sumit, if those are the configurations, those are the daemons which actually make our keyboards run, what is the usage of our drivers? Right? I mean, I'm pretty much sure that you would have seen disk drivers or hard disk drivers or mouse drivers or printer drivers. Those are peripherals. You'd have seen that for sure. Now what those driver does, driver certainly takes control of your peripherals, but whenever your Windows boots up, first time for the first moment, the control is provided to your peripherals, by means of which either you are able to punch in your login credentials, or you are able to press enter button, or perhaps your light glows in your keyboard. You would have seen it, right? Light glows immediately on your keyboard. How that happens? That happens when the basic configurations, when the basic booting happens on your Windows machine. Quite similar to that, friends. In case of Linux 2, we do have kernel. The kernel is something which is core section of an operating system, which does all the major procedures, which forms those, which provides memory, which provides resources for any of the processes to run. The kernel is basically in charge of creating an abstraction. What abstraction kernel creates? Kernel creates an abstraction for hiding hardware or application strategies by making all the processes which runs in sequential order, friends, all the processes which runs in orchestrated format in the ready queue and execute in return to avoid any kind of conflicts. Think about a situation when multiple processes are running on Windows and different processes are trying to occupy the process category or trying to occupy the queue at a time. It will be a deadlock situation, right? It's like two different processes are trying to perform same task at the same point of time. It will be a deadlock situation. So somebody should create a sequence, somebody should orchestrate it, and that is where kernel fits in, friends, right? Kernel creates that sequence, kernel creates that ready queue and allows all the processes, provides virtual memory to the processes so that it runs in sequential order and all the processes are executed in a sequential fashion. Now there are different varieties of kernel, friends. Certain kernels are, and this is just a high level overview, even though you don't know this, it's fine. But just to give you a high level overview, perhaps it might be a question in your mind, like the way in your Windows, when you go and purchase a Windows laptop, some may be costing 40K, some may be costing 45K, some may be costing 90K, some may be costing 1.5 lakhs, right? So what makes that difference? The difference which comes in Windows is perhaps processor is different, perhaps the hard disk drive is different, perhaps you're using SSD in your hard disk, right? Certain things are different. Similarly, even Linux do have its variations based on which its costing happens. They are of different types. They are of microkernels, monolithic kernels, axo kernels, hybrid kernels. Different type of kernels are there, which varies based on memory resources. Like the way in Windows we do have different memory resources, different memory capacity, your processing speed, frequency of the task which you can hold, your RAM, your snap storage, your buffer memory. So many things comprises of costing of your laptop, right? Similar to that, for a Linux variation also, we do have different varieties, different categories, like the way I said, monolithic, micro, exokernel, and hybrid kernel, friends. And the variation is on memory resources which they offer, virtual memory which they offer, address space which they provide, right? And speed and design of those kernel, based on which the speed of the operating system, speed of the booting, or speed of the your speed of your machine or server, it depends. So this is kernel. But friends, what is very much important for you to understand whenever you are working on kernel, the pretty much important section for you to understand will be main subsystem of kernel, like the way you are seeing as of now on my screen. Main subsystem of your kernel. What is the main system subsystem of your kernel? It's there in your slide as well, which we are going to offer you. But just to give you idea of what is main subsystem of kernel. So friends, main subsystem of kernel is its process scheduler, its memory management unit, and its virtual file system. And everything falls in a sequence, friends. Remember this, everything falls in a sequence. Just try to create an analogy with your Windows. Whenever your system boots up, what happens for the first time? For the first time, multiple process runs. And what actually requires for any process to run? For any process to run, friends, it takes processing time, right? Go to your task manager and see there will be a field, there will be a column which will be CPU usage or processing time for any of the daemon or any of the process which runs. Similar to that, friends, there is one subsystem of kernel to which we call as process scheduler. This process scheduler is responsible for distributing processing time in a uniform manner among all the concurrently running processes, right? Multiple processes may be running, and this process scheduler spreads across. This process scheduler this process scheduler fairly distributes processing time to multiple processes which runs in your Linux operating system. Second subsystem of kernel is MMU, which is memory management unit. I believe you would have already got the idea what memory management does. Process scheduler is allowing processing time for processes to run. But eventually when process runs, what they need, friends? They need certain memory for its execution. They need memory for everything to complete. They need memory for it to happen. For example, even though if you create a small folder, even though if you create small file, it it captures certain memory. That is a process. A process is creation of file. But when you create a file in your Windows machine, you will see it occupies certain memory. Similar to that, memory management unit in case of Linux allows those processes to capture certain memory. And the third point is, friends, virtual file system. And this is one of the quite essential thing. Memory which I was talking about in MMU, that is a virtual memory. You'd have seen C drive, D drive, E drive. Those are virtual segregation. Does actually your data lies in C drive, D drive, and E drive? No. I'm sorry, but no. Your data does not lies in C drive, D drive, or E drive. Actually, it lies in your hard disk, right? Actually, it lies in your physical hard disk, which is within your computer chassis. right? Which is within your computer cabinet. But you create a virtual segregation. You create a file system. You create a virtual segregation on your physical hard disk, to which we call as drives, which is C drive, D drive, E drive, wherein C drive contains all your operating system or your system configuration related components. Similarly, friends, in Linux also we do have virtual file system, by means of which we create a segregation, a clusterization, a bifurcation, a abstraction on physical layer, on physical media. All right. I'll give a quick pause here, friends. Anyone has any doubt in understanding what a kernel is, please ask me now. Because next we are going to talk about how the Linux system loads, right? What happens basically when you press power button in your Linux machine? And today's session is going to be mainly theoretical. I'll try to make it as interesting as possible, though I understand theory is a bit boring, but we'll try to make it as interesting as possible. And gradually, when we get into our practical session, it will be quite live, and I'm pretty much sure you're going to like that a lot. So any doubt till here, friends? Okay, fantastic. So let's talk about what happens basically when you press the power button in your Linux machine. Have you ever noticed, friends, what happens in when you press power button in your Windows machine? Nowadays it comes with a flash, right? As you press power button, the first thing which appears is your login screen. Should we know side by side operating system? As I have not learned in college, operating system or operating system as I've no need to learn, Bunny. What I am covering in my session, that will be enough for your operating system level knowledge. Please follow my classes. It will be enough. You no need to learn anything different from what I'm covering there in our session. No need to do that. I'll be covering that in my session. What Linux boot process is, what we need to know in boot process, how any of the what happens, what are the steps gets triggered in an orchestrated format when we boot up any of the Linux machine. I'll be covering everything, Bunny. So you no need to move anywhere. Just follow my class. That will be enough. Nothing other than that. Hope it sounds good to you, Bunny. Fair enough. So now what happens basically when you press on power button, like the way you're seeing on this screen, this image, we do have a power on. Consider that it's a power button, right? I just try to make it as similar as it appears there in my Windows desktop. A power but on, a power button. So what happens basically when we press power button? What happens basically when we click on that power on icon? What happens basically when you press on power on icon in your Windows screen? I'm pretty much sure, friends, all at a flash, you get your login screen, right? Correct me if I'm wrong. Correct me if anyone else. It performs the post operation. Great, Soumya. I believe you already do have understanding of post. Great. So uh, before post even something happens, we'll talk about that. Before post happens, and what actually triggers post, we'll talk about that. And what post is, we'll talk about that also. Soumya, great. But that was a great answer. So when we press power on button, friends, it triggers something. Like the way you can see on this screen, the first thing which is triggered when you press power button, even though it's your Windows, trust me, friends, even though if it's your Windows, first thing which starts when you press power button is it triggers BIOS, which is called basic input output system, right? BIOS is triggered, which is called basic input output system. So now whenever we press power button and whenever we create a bootloader is another thing, right? Absolutely right, Bunny. So BIOS is something which is triggered when we press power button. What this BIOS is, this stands for basic input output system. BIOS, friends, it contains all the codes, and that is where, if you did not notice it till now, just press power button, not now, after the session, press power button and try to see what flashes in the first place. Perhaps your light on keyboard will flash. Perhaps if you are connecting to your mouse, light in your mouse will flash. If you are connecting your hard disk, light in your hard disk will flash, right? What is happening? Why that flashes? when you press your power button. And same thing is applicable to Linux also. So when you press power button, it triggers BIOS. What BIOS does? BIOS contains all the code to gain initial access to main machine devices. What are the main machine devices? They are keyboard, they are display screen, they are disk drives, and some of the peripheral devices like mouse, like any other peripheral devices which is connected in your USB port. Perhaps light on your USB port will glow when you are hitting your power button. Okay, so this is what will gain sense when you press power button in the first place. So what it is actually doing, friends, what it is actually doing, parallelly I'll open a notepad and I'll create certain notes also which perhaps will be helpful for you, and you can refer that at any point of time. So friends, what you can do is, with BIOS, which is basic input output system, what you're going to do is, the first thing which it is going to do is, it is going to give life to main devices, starts processes management in Linux when we power on. Absolutely right, Bunny. And that is where it called boot processor, right? The way you said, right? Boot processor, it does that. Parallelly, what it does, friends, it performs some system integrity checks. It performs certain integrity checks on system, to which Soumya was saying it performs post, right? It performs post. What post is? Soumya was saying something about post. What post is? Post stands for power on self test. Post, it's not as in post as in post office, or post as in posting some message. It is power on self test. What is power on self test? Power on self test is an operation which is initiated by a computer after it has been turned on, but before its operating system boots up. So that is post. That is something which is initiated by computer. So even your laptop does that. Even your laptop do have feature of post, even though it works there as well, right? Because it is integrated with BIOS. Right, it is integrated with BIOS. BIOS is initiating post, which is power on self test, which is nothing but a sanity check. What it does, what post does. Post, as the name says, power on self test. It tries to find any error. Whenever it runs, it will either try to do either of two things, right? It will run test. So test result can be either positive or negative. Can there be something in between? Certainly no. It will be either positive or negative. If it's positive, you will get a green signal and you will move on. But friends, if it's negative, if you get any error, then it commonly shows an error message on the screen in red color, or perhaps in red cross mark. In case if the test fails, for example, I'm giving you certain example. For example, the test fails to detect the RAM, right? So what post will do? Post, and many times you'd have seen it in your Windows machine also, and I'm not sure if you realized or not, and correct me if I'm wrong. Many a times you'd have seen your Windows system gives a beep sound, like beep. It gives a beep sound, right? What is that beep sound, and who generates that beep sound? That beep sound, friends, is generated by post only. If your RAM, if your RAM fails to get detected, post triggers a beeping sound, a sound by means of which certain alarm will be generated. Absolutely, absolutely. 2 amber, 4 white for RAM issue. Absolutely, Samya. Great. Now, right, absolutely, Soumya. Yes, that is what it goes. Absolutely. RAM issues, right? So this is what we get in case of post. That is what we see in case of post configurations. So that is what post does. Now, once the post part is over, what is the next thing? Next thing is what, Bunny, you were talking about. Bootloader is triggered. Now the BIOS is up, right? Now the BIOS has run. BIOS has already performed the post check. And by using post check, the state of machine has been verified. Everything is fine. Okay, everything is fine. Now, post that, a boot order is triggered. Now we can configure, we can alter that order we can just make changes in that order. It's not like we cannot make changes. We do have control to make changes, but there is a default boot order. First, hard drives will come up, then USB drives will come up, then CD drives will come up. Right, nowadays laptop doesn't have CD drive. Nowadays laptops do have mostly hard drives and USB drives, but still those CPUs do have CD drives within it. So the booting process in Windows machine or any other machine in that context, in Linux machine too, follows this order. First hard drive, then USB drive, and at the last CD drive comes up, right? So in fact, a BIOS system has the boot loader located in the in the first sector of the boot device. Those do have more granular features to talk on, but mostly it follows an order. So for now, for to have understanding of how boot order comes up, what is the boot order? So boot order is default boot order is it starts with hard drive, then it goes to USB drive, and then it goes to CD drives, right? So these are the three orders which we are going to talk about. So what is the boot order? Boot order is first is hard drive, hard drive. Second is USB drive, and third is CD drive. Now I'm trying to compare everything because I know you're pro in Windows, and perhaps like the way Vineet was saying that he rarely saw Linux do getting used in any organizations. So if you have the comparison, because we use hard drive in our Windows, right? We use USB drives in Windows, we use CD drives in Windows. So you'll be easily able to relate. Okay, fine, boot order follows this approach, and quite the same thing is applicable there in Linux too. Though in Linux we do have some different set of commands by means of which we can see what the boot order is and how that works, which we are going to talk about in our upcoming discussions. Right? So now bootloader is done. Bootloader is done. Bootloader has configured it. But friends, Linux has a special feature which Windows does not have, right? Linux has a feature which Windows does not have, and that is where from this point of onwards Linux is going to be different from Windows. Now friends, after boot device there is something called grub configuration. So this bootloader do have different configuration. This bootloader will have different configuration. One of the most widely used configuration is called grub, right? One of the mostly used configuration is called grub. So how grub is different, and from this point of onwards, friends, your Linux will be different from Windows. So grub. So grub stands for Grand Unified Boot Loader. Okay, Grand Unified Boot Loader. And as I said, from this point onwards, your Windows will be different from Linux. Grub actually, Grub will have the capacity to choose configurations, to choose one configuration out of many choices. Like the way when you do have your laptop can have either Windows 10 or can have Windows 11 or can have Windows 8. It cannot have both Windows 8 and Windows 10 configuration. But in case of Linux machine, friends, we can have multiple configurations together, right? We can have multiple configurations together, and that is controlled by using grub. At the grub stage, friends, at the grub level, to which we call as Grand Unified Bootloader, it is we do get a choice to make. We do get an option by means of which we can choose, okay, fine, I want to go with certain specific version of Linux. Say for example, one of the Linux distribution is, and for now just take it from me, one of the Linux distribution is CentOS. CentOS comes up with multiple version: CentOS 6, CentOS 7, right? Different versions of CentOS there, CentOS 8. So you can have CentOS 7 and 8 together, configuration of CentOS 7 and 8 together while you are booting up. while you are booting up, and you do have the option to choose, okay, fine, which configuration you want to go on, okay, while you do have grub settings. So this is what grub does. Grub, from grub onwards, your Linux system will behave differently than your Windows. And now friends, after this stage, right, after this stage, my kernel will trigger. So you see friends, kernel comes so far, kernel comes so far, friends. Kernel is at this stage, right? And this is, if I talk about this architecture, you see kernel is somewhere which is, which acts as a medium, which acts as an interface in between shell and hardware. But kernel comes after your grub configuration. So once you chose, okay fine, which configuration I want to go with, after that friends, kernel comes, right? And kernel, what kernel is doing, like the way we discussed even before, kernel is going to provide a control to access our computer resources. When I say computer resources, nothing but it's hardware resources, right? So basically kernel follows, performs hardware checks. It provides access to all the peripheral hardwares. Let it be your mouse, let it be your hard disk, let it be your printer. All the peripheral hard disk, all the peripheral configuration is offered by kernel only, and that is where kernel comes in, right? So now whenever this kernel is launched, friends, whenever this kernel boots up, whenever their kernel rises, whenever this kernel wakes up, it triggers two different processes. One is systemd and another is a run level. So what is systemd? So systemd is a process, is the, is the, we can say it's a parent of all Linux processes. This systemd is used to perform certain tasks. For example, in case of Windows, whenever your Windows boots up, after your Windows boots up, perhaps it might, perhaps immediately after your Windows boots up, it takes some time for icons to reflect in your desktop. I'm not sure if you would have noticed or not, or if your computer is super fast, I'm not sure. But in case, what happens with me, and I have noticed it a couple of times, when my Windows boots up, it takes few seconds for icons to display in my desktop. So what is desktop? Desktop is a folder. If you go to C drive, you will see desktop as a folder, right? So items in desktop folder take some time to load. Why it takes some time to load, friends? Have you ever thought for it? If not, then let's think now. It takes time because it tries to mount the data. It tries to pull the data from physical memory. And what is the physical memory? Your underlying hard disk, which is mounted by your C drive. So this systemd, which is initiated by kernel, initiates or mounts those file systems, right? It initiates a number of different daemon related services. It runs a desktop environment. It manages a number of essential system processes like user login and many other things, right? It does many other things. And other than that, it also talks about a number of different run levels, right? The way it says run levels. Basically, run level is nothing but it is something which is current state of your operating system. Run level basically defines which system services are running previously, right? This is what runs levels are, right? The way run level says, run basically means current state of the operating system. What is running as of now comprises of running level. So kernel wakes up, kernel pushes life in run levels and systemd, and these both wakes up, right? So this is what we call as the life cycle of a process. Sure, Soumya. So what systemd does? Systemd is nothing but it is quite similar, like the way whenever your Windows boots up, it takes some time for each of the desktop or data in your folders to map with your physical disk, to map with your file system, to map with your drive, which you have created just now, right? So systemd is nothing but it's a process right? It's a Linux process by means of which mount of file system happens, by means of which all the services, all the daemons gets initiated, by means of which certain processes like login processes wakes up, by means of which various environments which is present in your machine, which is present in your system wakes up. So system D basically brings or pushes life in a number of daemons, number of services which you actually need to work efficiently on your machine. Like the way if I click on Windows, it opens me a Windows Explorer, right? It opens me a Windows Explorer. How does it open a Windows Explorer to me? Because some process runs at the back end. That is system D, which triggers those processes. Does system D do the same process management? Yes. Does system D does same process management? Yes. Great question, Soumya and Bunny. Anyone else? Any other question? Perfect. Okay. So now let's move on other process. Let's talk about what your virtualization is. What do you exactly mean by virtualization, friends? And this is very much important what I'm going to talk about now. Concept of virtualization, friends, I'm going to talk about now, right? Concept of virtualization. And before I move on, I'll give a quick second. Whatever I'm covering as of now, is it understandable? Are you able to follow me? Are you getting what I'm covering, friends? Please give me a quick response with a yes, no, maybe. Anything is fine. Okay, thanks, Soumya. Soumya gave me yes, sir. Nizamuddin says yes. Great. Okay, perfect. Yes, writing it down notes. Great, Bunny. Awesome. Okay, great, Kumar. So friends, now we are going to talk about concepts of virtualization. What exactly is virtualization? What exactly do you mean by virtualization, friends? I'm talking so much about, okay, Linux. I'm talking about so much about you're having a Linux in your machine. But friends, I'm pretty much sure that you would have heard about this term, virtualization, or at least in your organization, you'd have seen. Please provide me. Suddenly, I share. No problem, Kumar. So, what happens in virtualization? So, friends, I'll create an analogy this time. What happens in application lifecycle? And from my experience, I'm telling friends, developers require multiple operating system to build different operating system. And I'll create an analogy here. I'll give you one scenario. So friends, you might have Windows laptop, you might have say Linux laptop, you might have Mac laptop, you might have Windows 8 laptop, you might have Windows 10 laptop, you might have Windows 10 Pro laptop, you might have Windows 11 laptop. But whenever you click on browser, or whenever you try to open any website, or whenever you try to install say Notepad, does it vary? Does the process vary while you're installing any of the software, or whenever you're using opening any website? Consider Amazon, Facebook, WhatsApp web. If you're opening on your browser, does it make any difference? Let it be Windows, let it be Mac, or let it be Windows 8, let it be Windows 10 plus. No, it does not. Why it does not? Have you ever thought of it, friends? If not, let's discuss about it. So it happens, friends, because it's it's platform agnostic, it's OS agnostic, it's independent of operating system, it's independent of platform. How it is independent of the platform? It is independent of platform because while developers develop those applications, while developer writes source code for those application, it it is it is tested on multiple operating system. For testers, it's like they are testing on multiple operating system. Whenever we create virtual PC from using single physical PC, using its memory, CPU, etc. Absolutely right, Soumya. You got the idea about having a virtual PC created, a virtual machine created, which is created on your physical, on your laptop or desktop, whatever it is, right? Absolutely right. So now, friends, if you're a Windows user, you will not be able to use Linux application without virtualization software. And I bet on that. If you're a Windows user, you will not be able to use Linux application without virtualization software, friends. And it's fact. and it is applicable to other operating system as well. If you're a Linux user also, you cannot use Windows. If you're a Mac user also, you cannot use Windows if you don't have virtualization software enabled, installed on it, right? And we use virtualization software for multiple reasons. It is used for virtualizations, it is used for networking functions. And friends, you would have seen data centers you would have seen in maybe in movies, or maybe in case if you got an opportunity to get into a data center. Those data center contains big racks. Those rack contain so many wired servers, so many wired infrastructure, so many wired boxes, right? And friends, those data centers, those wired boxes actually acts actually do have virtualization configured in it, because those servers are huge, friends. Those have petabytes of data. Those have petabytes of data. And we cannot run one single application, or we cannot have one single software configured on petabytes of data, or we cannot use petabytes of data altogether. It's quite similar like the way you are creating bifurcation abstraction on your Windows machine, wherein you keep your system related files in C drive and other files in your D drive, E drive, or other drives which you create, right? It's quite similar to that. So we create a virtualization, we break the memory, and we use that memory to launch another operating system in this case, right? That is called virtualization. So friends, for virtualization, we use certain software. Without software, virtualization does not happen. And software which is used for virtualization is hypervisor, right? Hypervisor. So what is hypervisor? Hypervisor is a software. By using hypervisor, you will be able to enable virtualization in your machine, right? You will be enable virtualization in your machine. So hypervisor creates abstraction on operating system and applications, so that different virtual machines of different operating system can run on your laptop. For example, if you are using Windows, friends, you can use Linux. And I'm going to show you. See, this is my Windows desktop, right? But I am having this Linux based operating system here, Linux machine here. And friends, you are also going to do that. I'm going to show you how to configure this in your machine, right? We'll see that. So hypervisor is the software compressing the hardware uses through the virtualization. uh, not exactly in that way, Nizamuddin. It's not only compressing the hardware usage, it's not only restricting the hardware usage, but it's creating a separate space. It's allocating certain memory wherein you can create a virtual machine of different operating system. It is something like the physical hardware that a hypervisor runs on is called host machines, right? So in my laptop, if I'm installing hypervisor, my laptop is called host machine, and all the virtual machines which we are creating on my laptop is called guest machine. So we do have host machine configuration and guest machine configuration. Host machine is where my hypervisor runs, and guest machine is all those machines, all those operating system, all those virtual machines which we create on my laptop, right? So virtualization with a hypervisor increases your machine's efficiency. Perhaps if your machines, if your laptop do have capacity of 1 TB, maybe you will not be able to use it. So why not to have other virtual machine configured on it, so that you can easily learn usage of other virtual machine also. So that is by installation of a software to which we call as hypervisor. So hypervisor creates certain spaces. Hypervisor creates certain abstraction on memory. So now friends, hypervisor are basically of two types. These are of two types. What are those two types of hypervisor? One is type 1 and another is type 2, right? Type 1 and type 2 hypervisor. So what is the difference in between type 1 and type 2 hypervisor? Let's quickly understand that. So type 1 hypervisor runs directly on host machine physical hardware. It runs on physical hardware, friends. right? It runs on physical hardware. It is also known as bare metal hypervisor. Bare metal hypervisor. It comes many times in interview question also. What are the different types of hypervisor? Which hypervisor is better, type 1 or type 2? It comes many times in interview also. So friends, type 1 hypervisor is most efficient one. Why it is most efficient one? Why it is best performing hypervisor? And why it is widely used in enterprise level industries? It is used in enterprise level industries because friends, these type of hypervisor is used to run directly on physical layer, right? It runs directly on physical layer. It runs directly on physical hardware. And since it runs on directly on physical hardware, it mitigates the risk of attacks that target security flaws. Nowadays, we have so many hackings, bugs. You'd have seen, okay, fine, somebody inserts pen drive and hacking happens and they steal data, they compromise data, and many of the data breach happens. With the usage of type 1 hypervisor, those things can be minimized. Security flaws can be minimized. Virtualization vulnerabilities and OSs can be minimized because each guest in this case, right? Because each guest, so in hypervisor, we do have host and guest setup, host and guest architecture, because each guest will have its own operating system. So that is where type 1 is better than type 2. So type 1 is something which runs on better bare metal server. Type 2 runs on operating system, right? It runs on operating system. Some of the example of type 1 hypervisor, some of the example of type 1 hypervisor is it is Oracle VM, which is Oracle product. Hyper V. Okay, I'm writing it wrong place. Cut, paste. Hyper-V is there. vSphere vSphere is there. Hyper-V is Microsoft project. So let's write Microsoft. Hyper-V is there. KVM is there. KVM is there. So different examples of type 1 hypervisors are Oracle VM, Microsoft Hyper-V, vSpheres, and many others. There are VMware vCenter also, right? Many other examples are there which works on their VMware vSphere also. These are the different examples of VMware. Absolutely. VMware is there. VMware is there. It is an example of type 1 hypervisor, right? This is an example of type 1 hypervisor. So, okay, fine. A quick check, Bunny. So, do you know VMware is a subordinate of which company? Because we listen VMware a lot, right? VMware is a subordinate of which company? No, it's of Dell. Okay, so VMware is a subordinate of Dell Technologies. Okay, so now there is another type of hypervisor that is called type 2 hypervisor. So what is type 2 hypervisor? Type 2 hypervisor, as I said, it's installed basically on operating system. Some of the examples of type 2 hypervisor is, anybody wants to guess? Oracle product? Anybody wants to guess? Oracle VirtualBox. I'll write it. Oracle VirtualBox. And there are some other softwares like Parallel Desktop is there. Some of the examples of type 2 hypervisor, right? Very important, friends, from interview perspective. Very, very important from interview perspective. Now, quickly, let's jump into our Linux distribution. Linux distribution. And from here, friends, things will be very, very interesting for you, because now we are going to switch into some of the practical component. We are going to just see how the practical configuration, how the practical implementation of Linux looks like. So friends, Linux distribution, also known as Linux distro. What is Linux distro? What is Linux distribution? Linux distribution is something which is built out of Linux kernel. It is an installable operating system. What is Linux distribution? Installable Linux operating system. Operating system built in Linux kernel, right? Which is built in Linux kernel. This is what Linux distribution is, friends. Type 2 is Solaris. No, Solaris is one of the flavor of Linux. We are going to talk about that, right? We're going to talk about that. So Linux distribution is installable Linux OS operating system, which is built in Linux kernel, right? So now, friends, Linux distribution are of two types. Like the way whenever you install, I'm pretty much sure you would have heard about ChatGPT. ChatGPT comes with two different versions, enterprise version and community version. Similar to ChatGPT, any other software in this universe comes with two different versions, enterprise version and community version. What is enterprise version? What is community version? So normally community version is open source. It's free to use. Its source code is free to use. But with community distribution, you do not get all options. You do not get all features. For that, what each of the organizations say, you purchase licenses so that I can provide you more features. I can help you getting your specific query addressed, right? Like the way you create your account there in any